Hey folks, hope all is well. We're going to continue today with finding volume using cylindrical shells, so that's section 8.4 in your textbook. It'd be a good idea to go back and read the second example before we move on with it. So we're going to take a look at two examples today. One of them, actually both of them, are going to have an axis that does not touch the shape which we're rotating. We're going to take a look at the first one, take a look at the second, and then you have three problems you're going to do. Let's take a look at that first one. So we're going to take a look at today how do we use cylindrical shells when the axis of rotation doesn't touch the shape. Here's our first example. You might want to pause the video and write it in. I got this graph by just plugging this into Desmos and it graphed it out. This does extend further in a sideways parabola. I just didn't write it because this is the only region we need. Now this is going to rotate about the axis here. So we're going to wind up with another shape here and a parabola. And our shell is going to end up looking like this. Now we just need to figure out everything we need. It's going to be a bit different because it's going to be in terms of y instead of x, but going to be the same deal. First things first, the circumference. Well, the circumference here is just given by 2 pi r, and here circumference is just 2 pi y. The reason it's y is because the radius here is given by the y value of the point. Now the height here is from here to here, this side of the cylinder. The issue is that side of the cylinder is from the x value to 0. All the x values here are going to be negative, so what I'm going to have to do here is do 0 minus x. That way, since these are all negative, it'll be 0 minus a negative, so positive. I want it all in one variable. Well, I know that x is equal to this. So this is just going to be the reason that all these switch sign is because this is going to switch them. Last but not least, the thickness. Well, that's just going to be dy. Now our bounds for our integral. Well, this is in between 6 and 4. So those are going to be our bounds. Let's clean this up a bit and make it look how we want. So I took the constant out. That's out of the way now. This is all just going to be a power function. So we're going to integrate. All of these just increased because it's a power function. And I put the new exponents here. Because this is a definite integral, I'm ignoring the plus c. With a bit of algebra after you do it out, our volume is just going to be, and that's the exact volume of this space. So you notice that I skipped the algebra there. It's just because we have limited time in the video and I don't want to take it up. If you have any questions about the algebra, see me during office hours, or use an integral calculator like the ones I provided on Google Classroom. We're going to take a look at another one where the bounds are already given, and we're going to rotate around another point. Again, we're going to skip the algebra. If you're interested about it, use the integral calculator. Let's take a look. So here's our second example. You might want to pause the video and write it in. It's a bit weird looking. I tried to color code as best as I could. We have our original function in pink, we have our bounds in orange, and we have our axis in blue. We're still going to do everything else that we've done. We need to find the circumference, we need to find the height, and we need to find the thickness. So our circumference here, well, it's just going to be 2 pi. And then we need our radius. Our radius here is actually going to be 3 minus x. The reason it's 3 minus x is, since this is our axis of rotation, from here to here could be my radius. It depends. X can be any value between these two bounds. It could be as much as 2 for a radius, could be as little as 1 for the radius. Now, the height here is just going to be y, because that's just how tall the cylinder is. And the thickness here is just going to be dx. That's how wide we make our cylinder. And what this is going to end up doing is giving us a cylinder that looks like this. Well, we know what y is. Y has to be x to the negative 2. Everything's in terms of x. Dx comes on down. We know our bounds, so let's set up our integral and make it a bit easier to work with. So that's our integral. We're now going to integrate it. And if you follow through with your integration rules, it's going to be a bit weird because you're going to need natural log. You're going to wind up with cool. Last but not least, you evaluate using algebra, and you're going to wind up with and we're done. So I hope you're seeing the similarities between the two, where we're just finding the circumference, and that has to use the radius. We're finding the height, and then we just need to use the thickness. Thickness is always going to be your differential. So give those problems a shot. They're listed in the assignment, and then post them in the Google Doc. If you have any questions, see me during office hours. Hopefully you're watching this video well before the Friday deadline, so you can ask questions. If not, please reevaluate the choices which have led you here. Have a great day, folks, and stay safe.